Hello, welcome to a new video of Big Brother 161. And today we will see many characteristics and everything you need to know about the debug screen, or the F3 screen, which is the closest thing we have to the Mandalorian helmet or the Iron Man helmet. If we place F3 inside the game, we will see that all this data is displayed. So if we go to the browser and search for the debug screen, you will see that each database is displayed depending on the column or in the line of each of the variables we want to see. But instead of just reading all this text, I prefer to explain this on a video, so let's begin. The first thing to appear is the Minecraft version we are playing. In case we are playing a modded version, it will say so. In the second line we can see the frames per second. The T indicates what is the limit of frames per second we have in our system. In this case it's 50. If we go to the menu, then we go to video. Here we can see the max frame rate measured in FPS. So let's move from 50 to 70. And now you can see that T is 70. Then we will see some configuration of our graphics. Here for example it says fancy. Our graphics are quite advanced. And then you can see how our clouds are configured. In this case fancy again. Menu again, we can see graphics is fancy. We can also increase it to fabulous. We can also configure the VSync, we can change it, and now we can see it in the screen again. The next element is the biome blend represented by the B. Here you can see it set to 2 blocks. This will change the rate at which water or things like grass change depending on the biome. So here we are in plains, then we pass to the biome dark forest. So if we go to options, video, we can go to a minimum where there is no blend, and as you can see here, there is a clear division for which biome is which, where B is 0. So let's increase the blend up again. So we can pass it to a 7x7 configuration. You can see that the blend is 3 blocks, and the transition to another biome is less clear. In GPU we can see the percentage of the estimated use of our graphics board. Integrated server means that I am using my own PC as the host for this world. And MS is the velocity at which the server is running. TX is referring to the packages of information that are transmitted, and RX are the received packages on the client side. These both variables refer to the communication. C is referring to the number of chunks that are being renderized over the total number of chunks that are being loaded on this area. D is the distance at which we are renderizing, in this case 10 chunks. In the menu we can change the render distance, for example 15. Now it reloads the chunks, and you can see the variable is now 15. PC is the number of chunks that are waiting to be reloaded. PU is the number of chunks that are waiting to be reloaded on our graphics board. And AB is the number of buffers that are waiting to increase the response speed of our server. E is the number of entities that are being loaded over the total number of entities that are being loaded on these chunks. In this case we can only see 1 out of 158 or 156 entities that are in our local area. If we change our view direction, for example towards this river, where there are some fish and squid, we can see that this number increases, even if we throw some items to the ground. B is a variable that currently is out of use, so it will always mark 0. SD is a simulation distance within which a lot of mobs are going to take action and perform some tasks. If we reduce this distance, for example this donkey that is over there will parallelize in time. P is the number of particles that are being loaded in the world. For example, if I run, this number is going to increase because we do generate particles when we run or sprint. T is the total number of entities that are being loaded on our world, including mobs, particles, etc. Chunks with a capital C are the number of chunks that are being loaded per client, displayed on how many there are on the west and on the east. Chunks with a capital S is the same thing, but on the server side. Just under you will see in what dimension we are located, and FC is the number of chunks that are being loaded with the command force load. Then you will see the coordinates of our position displayed on the variables x, y, and z. In the first person view you will see these arrows here on the center. X is being represented by the red vector over here, pointing towards positive X. The green vector represents Y, which is pointing upwards, and the blue vector represents the variable Z, which is pointing southwards. Black is a rounded down variable which indicates the position of our feet. Followed, the relative position of the block we are located in inside the chunk. So for example, let's press F3 plus G, and you can see here we're inside a chunk. And if we head towards positive X, or the red vector, the first number is going to increase. And just when we get to the border of the chunk, we're going to see this last position. And if we cross the border, we're going to see that this relative position changes. Chunk is the number of the chunk where we are located. So if we go to a border and change the chunk, we're going to see this number change. I understand that this information indicates where the player is located currently. Now we have this variable that tells us where we are facing. For example, here north, which is this direction. And if I turn slowly, you can see that here we change towards east just when we reach the 45-degree angle. Now 45 degrees passing the east vector, we can see that we're facing south. The direction is west, and here we are facing north again. Now inside parentheses, we can see these two numbers which represents angles. The first angle represents the horizontal deviation we are taking. A 0-degree angle represents we are facing exactly south. If we turn left, we are going to see that this angle is negative, reaching all the way to minus 180. But turning right from the south, we're going to see that the angle is positive, and reaches all the way to 180. The second number represents the angle that tells us the deviation from a horizontal plane. If we start facing up, we're going to see that the angle is negative all the way to minus 90. And we start to face downwards, we're going to see that this angle is positive all the way to 90. The next number represents the value of the light we're being exposed to. But if we go underground and submerge under one water block, we're going to see that the light is 14. And if we go away from the hole, 13, 12. And if we completely close off the hole, the variable will indicate 0. If we place a torch, you will see that the skylight is 0 because we are completely closed off. But the torch is technically a block which is emitting 14 light level. And if we go further away from the torch, this variable is being reduced. So the first value is going to mark the highest value of either skylight or block light. In CH, the first value is going to mark the highest block on the column where we are located. So my feet are position 70, and you will see that the block under is 69, because it is the highest block. And now we can see this value being increased. So leaving this block up there, we're going to place ourselves just under it. As you can see, we're in height 70, and the CH marks the block 75. SH tells us the value of the highest opaque block on this column. So if we place grass, you can see that it's not being marked. And if we place glass, it is being marked. Weird Minecraft stuff. Now, SH refers to the same thing, but from the server side. O is the highest block on this column, which is able to block movement. M from the server side is the same as the M on the previous line. And ML is the value of the highest block on this column, which is not a leaf block. Here you can see the leaf column increasing, and it will always mark 75, the block under there. Biome marks the biome where we are located. For example, here we are on plains. And if we go to a dark forest, you can see that this variable changes. Next is the local difficulty, and this goes through various levels. For example, peaceful is 0.0, easy goes to 0.75, normal is marked 1.5, hard is 2.25. But of course this value continues to increase depending on how many days we have been running our world. For example, here is day 0, but if we increase some few thousand days, this next part just counts in words that are being hosted on your PC, so this does not count any external servers. The next variable is going to mark what type of blending we are using. For example, here you can see it is old, and in the case that this is not old, it will not mark anything. This part is going to make noise router or multi-noise, This indicates a number of variables that are being used to generate the terrain on our world. T is temperature, which is not going to affect the terrain generation, but it is going to affect the kind of biome it is generating. V is vegetation. C is continentalness, which is used to differentiate between continents and oceans. E is erosion. That indicates how elevated or how flat a terrain is. D is depth. W is weirdness. This indicates how weird a terrain is, and is going to indicate if this is going to be a mountain, a valley, a river, or anything between. PV is peaks and valleys, which is derived from a noise value. And the S and N are noise values that we could not determine. Biome Builder is an motor used to build terrain, and is also used to determine terrain and biomes. PV, as the previous value, is also referred to peaks and valleys. C is continentalness, and it determines if it is going to generate for mushroom fields, deep ocean, coast, near islands, near inland, or far inland. ET and H are erosion, temperature, and humidity respectively, which are some more noise values. SC is the number of chunks that are being used to spawn mobs. This usually marks to 189, which is the number of chunks that are within our action radius. The first M refers to hostile mobs. C refers to passive creatures, for example cows, sheep, chickens. A refers to ambient mobs, for example bats. U is underground water mobs, for example glowing squid. The first W is dolphins and squid. The second W are ambient water mobs, for example fish. And M are miscellaneous mobs, which I cannot determine which these are. I tried with item frames, armor stands, and even tried throwing some snowballs, but nothing. Sounds is the number of sounds being reproduced over the total number of sounds that can be reproduced, plus the number of sounds that are able to be streamed. Here we can see there is 0 out of 8. The example we have of these streaming sounds is playing a disc. The next value is mood. You can see, for example, if we come to Nether, this value slowly starts to rise. After some time we are going to see that the mood closes to 100%, 98%, and when it reaches 100, it reproduces one of the special sounds. Next we will see in debug, if we press F3 and shift, we will see the debug pie. And if we press F3 and Alt, we will see the FPS and the TPS. And finally on this column we will see that to see the help menu, we have to press F3 and Q. And if we press 3 to open the chat, we can see the suggestions of the various combinations of F3. But we will see this on another video. Let's move to the column of the right. In the first line we will see what version of Java we are using. Then we will see the percentage of our RAM memory that is being used, followed by the number of megabytes of the RAM memory that is being used over the total number of RAM memory that is being designated to run the game. Then we can see the allocation memory rate per second. Then we will see what percentage of the memories has already been allocated, for example 100% or the 2048 megabytes designated to the game, followed by the number of data of our PC, for example the CPU. Then we have some data of our screen and our resolution. For example here we have my display. This is my NVIDIA board, followed by more data from my board. And pressing F3 facing a block, I can see a lot of the data from that block. For example, first you will see the exact position, what block I'm watching, you can see this is grass, and more data related to that block. In this case, for example, I can face a log. You can see there is a bunch of data. Here you can see the axis of orientation, what is the tool appropriate for this block, if this block is able to burn. So this video is getting long already, but I want to make a separate video to explain what are the combinations of the F3. For example, here you can see on this menu, display by F3 and Q. This has been Beerwater161, and remember, I will be scanning you.